Hello, this is Afnan Al-Subayhin. I'm an assistant professor at King Saud University. I'm here to present our work comparing similarity detection techniques for mobile apps using text-based artifacts. But first, let me introduce the problem. Recently, it seems that mobile devices are dominating personal computing devices. It then follows that many more developers are now tasked with developing mobile applications. Majority of apps are downloaded using app stores. This research by Lim and others found that less than 1% of users do not refer to the App Store for app install or discovery. Therefore, it can be deduced that app stores pose as the main software deployment repository for mobile apps. This prompted a previous study in which we looked into how exactly the app stores are modifying or aiding the software development procedure during all life cycle stages, focusing in particular on how it affects the software development life cycle, whether it introduces a new set of best practices and skill sets, or new sets of success criteria and measurements. We found that the majority of respondents agreed that they frequently survey similar apps on the App Store to discover or elicit requirements and find new enhancements. However, finding similar apps in the first place might not be a trivial task. App stores house a large number of apps ranging between 1.5 and 2 million apps. The app stores contain categories that convey an application domain. These categories are largely broad and convey a main theme rather than a proper useful classification for developers. This is confirmed by previous studies in which they found that the App Store categorization is not sufficient when trying to find apps that are very similar in terms of their functionalities and requirements. This is a quick example to illustrate this point. Both Elevate Brain Training app and Blackboard, a learning management system app, although they share very little functionality, they can be found in the same App Store category, which is education. On the other hand, CogniFit, an app that is very similar to Elevate, in which they both provide brain training games, CogniFit can be found in an entirely different category, which is health and fitness. So we thought, could we find a better categorization that can detect that CogniFit indeed fits with Elevate, while Blackboard, for example, fits with Google Classroom, just by looking at their descriptions. Their descriptions clearly state their functionality, their goals. So in order to investigate this, we looked into 5 different feature extraction techniques that have been heavily used in similar empirical software engineering research. These techniques are starting with the baseline, which is the vector space model using TF-IDF weighting, the vector space model using latent semantic indexing. We also looked into using topic modeling, LDA. We looked into using 2 different keyword extraction based techniques. The first extracts keywords based on collocating words. The second extracts keywords based on dependency parsing of the sentence to find specific sentence patterns that could indicate the expression of a functionality. To test this, we used a data set that is completely uniformly randomly sampled from the Google Play App Store in 2014. The dataset contains around 13,000 apps from all different 24 categories in the Google Play App Store at that time. We looked into these research questions, starting with a sanity check that checks whether the clustering that results from each of these 5 different feature extraction techniques is different. For each technique, to test the difference, we looked into the Jaccard similarity measurement. The second question, we looked into the App Store categorization as a clustering solution for each of these techniques to see if the clustering technique can represent a better clustering solution for the App Store categorization. The second research question looks into what is the granularity level in which each of these techniques achieves its maximum quality. We tested the quality by measuring the silhouette score, which is a score that measures the quality of clustering solutions. It ranges between -1 and 1. The second question looks into the quality not based on the silhouette score, but based on human judgment. The final question looks into the efficiency of each of these techniques. So, to answer the first research question, yes, each of these techniques is different. Perhaps the most similar is the collocation-based keyword extractor with the dependency-based keyword extractor, but this is to be expected since they perform similarly. The second research question shows that the current App Store categorization, when we calculate the silhouette score for the current App Store categorization, which is K equals 24, is very, very low indeed, and indeed needs improvement. The best granularity level for each of the techniques, we find that LDA can produce the highest silhouette among each of these techniques at the granularity level 5700. We also note that VSM with LSA produces a passable silhouette score with a coarser granularity than each of these techniques. What is the quality of each of these techniques based on human judgment? To measure this, we ask human raters to rate the similarity between randomly sampled app pairs on a scale from 1 to 5 according to 3 different similarity criteria: the feature similarity, the application domain similarity, and the possible API similarity. We calculated the correlation between the assigned similarity score and the highest K that these apps pairs remain together. We find that inter-rater agreement can be low for some of these pairs, but overall it is passable. In general, we find that LDA as well as both the keyword extractor techniques perform well according to human judgment. VSM with LSA performs very well, but only in application domain similarity. However, the efficiency of each technique, the ones that perform well as expected, cost more. So LDA can cost up to 5 days in order to do any data processing, as well as the collocation and the dependency-based techniques. Generally, our findings show that App Store categorization is not a good clustering solution as it stands. And we also show that the silhouette score, although informative, is not sufficient to measure cluster quality. Human judgment is indeed needed, and we've shown that it can vary. Using any of the studied techniques enhances over the baseline, which is the vector space model using TF-IDF, but using LSA helps converging to a coarser granularity with a passable silhouette score. App similarity can be challenging even for humans. This is shown by the sometimes low inter-rater agreement. Thank you for listening. To conclude, in this presentation, we showed that descriptions are an important source for developers from which they perform requirements elicitation and keep abreast of user expectations in an application domain. However, finding functionality or functionally similar apps may not be a trivial task. App Store categorization have been found to be inadequate. This study looks into clustering mobile applications based on their textual descriptions. It measures the applicability of 5 common feature extraction techniques. We uncover several findings that are helpful for carrying out this task. Thank you for listening. I'm up for any questions.